Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the evolutionary process models and prescriptive process models. Business and product requirements often changes as the development proceeds, making a straight line path to an end product unrealistic. In such a cases, the iterative approach needs to be adapted. Evolutionary process model is also called as the iterative process model. Evolutionary models are iterative. They are characterized in a manner that enables you to develop increasingly more complete version of the software. Second one, prototyping. Software prototyping refers to the activity of creating the prototypes of software application, that is incomplete version of the software program being developed. It is an activity that can occur in the software development, and it is comparable to prototyping and also known for other fields such as mechanical engineering or manufacturing. When we can choose the prototype, a customer defines a set of general objectives for software but does not identify the detailed requirements for function and features. The developer may be unsure of the efficiency of an algorithm, the adaptivity of the operating systems when requirements are fuzzy. The prototyping assists you and other stakeholders to better understand what is to build whenever the requirements are fuzzy. The prototyping paradigm begins with the communication. You meet with the other stakeholders to define the overall objectives for the software, identify whatever the requirements are known, and outline areas where the further definition is mandatory. Next point, the prototyping iteration is planned quickly and modeling in the form of quick design occurs. A quick design focuses on the representation of the aspects of the software that will be to the end users. Example, human interface layout or the output formats. Next one will be the evolutionary process model. First one will be the communication. After the communication, the quick plan phase, and then modeling, quick design, followed by the construction of the prototype phase, and then last one deployment, delivery, and the feedback. The quick design leads to the construction of the prototype. The prototype is deployed and evaluated by the stakeholders who provide feedback that is used to further refine requirements. Iteration occurs as a prototype is tuned to satisfy the needs of various stakeholders while at the same time enabling you to better understand what you need to do. Ideally, the prototype serves as a mechanism for identifying the software requirements. If a working prototype is to be built, you can make sure of using the existing program fragments or apply the tools, example, report generators, window managers, that enable the working program to be generated quickly. Next one, in the most project, the first system build is barely usable. It may be too slow, too big, awkward in use of all the three. There is no alternative but to start again, smarting but smarter, and build a redesigned version in which these problems are solved. The prototype can serve as the first system, the one that Brooks recommends you through away. But this may be an idealized view, although some prototypes are built as throwaways. Others are evolutionary in the sense that the prototype slowly evaluates into the actual systems. Next point, both the stakeholders and the software engineers like prototype paradigm. Users get a feel and the actual system, and developers get to build something immediately. Next one, advantages. Here we have the six advantages. First one, user are actively involved in the development. Next one, since it is a methodology, a working model of the system is provided the user get a better understanding of the system being developed. Third one, errors can be detected much earlier, and then quicker user feedback is available leading to the better solutions. And then missing functionality can be identified easily. Confusing or difficult functions can be identified requirement validation. Quick implementation of incomplete but it is further applications. Next one will be the disadvantages. The stakeholders see what appears to be working version of the software, unaware that the prototype is held together, unaware that it is to be rushed to get working with, have not considered overall software quality or the long-term maintainability. Software engineers make implementation compromises in order to get a prototype working quickly. And then usage of prototype. Although problems can occur, prototype can be an effective paradigm for the software engineering. It is then discarded and then actual software is engineered with an eye towards the quality. Thank you.